Hello, class. We're ready to do Module 8. We'll be using Chapter 11 out of the textbook. We're going to be doing two things, correlation and regression. We're going to use the Pearson and the Spearman out of the textbook. In the course project, we're going to present some data and provide a little analysis to get along with that. Let's start out with talking about the correlation and regression. While I'm thinking about it, uh, I think I sent you a chapter 4 that we had been working on, and it was completed. It was done with a correlation and regression analysis, and it's a pretty good one too. So if you have that chapter 4 and you're looking at how to use correlation and regression analysis, we used the Pearson there, so I think you will like it. There are two types, the Pearson and the Spearman, and we're going to talk about those. Let's just start out with an example of how it's used. Uh, an instructor wants to discover if there's a correlation between the length of time spent taking an exam and the grade on that exam. The instructor gathers two pieces of data for each student, the minutes spent taking the exam and the grade on the exam. And here's what happens. Like any good high school or college chemistry physics student, we're going to draw a graph, find out what happens. Put time down here, and we talked about grade being dependent on how much time, so we usually put the dependent variable on the y-axis. We don't have to always, but we do. So we graph that, and we get all these dots, and then as we did in high school, probably not in college, but we drew the best straight line we could find through here, the one that we thought was going to be closest to all of these dots. Well, there's a mathematical process for doing that. Fortunately, SPSS will do that for us. As a matter of fact, you take these measurements right here, and you take this one and divide it by that one, and you've got the slope of this line. I think you probably remember that from your college algebra class. Here's the hypotheses. There is no correlation between the length of time spent taking the exam and the grade on the exam. And then there's the motivated hypothesis. We're not going to read that right now. This chapter covers two kinds of correlation, the Pearson, and the big thing about the Pearson is it covers continuous variables, and then the Spearman will help you analyze categorical data. This test is a little more powerful, the Pearson than the Spearman, but each have their place in the statistical world. The Pearson is the most commonly used correlation, and anytime you hear someone say, I'm doing a correlation, they're probably talking about the Pearson, unless they specify differently. We're going to talk about two continuous variables here with the Pearson correlation. We have grades on one side, time on the other, and we're going to have some kind of a correlation here between this data, between grades and time, and it looks like the slope of this line is a positive and upward, so it's positive correlation, and really that direction doesn't matter with the strength of the correlation. The strength of the correlation is called an R value when you're talking about the Pearson correlation, and this one just happens to have a value of 0.815. They have to run between -1 and +1, and we always take the absolute value of it anyway and just talk about the positive value of the correlation. They'll never be over 1 and they'll never be less than 0. And this one happens to be about a 0.8, and we'll talk about what that means as we go along. It determines the strength of the correlation. And the R value, I've got Popeye and some kind of weakling down there. It's probably my cousin, who is the weaker side of this thing. But anyway, that's the sign plus or minus only indicates the direction of the correlation. It doesn't have anything to do with the strength. It can be just as strong in the negative direction as it is in positive, and it can be just as weak as it needs to be all the way to 0 if you have a correlation. So when you get those correlations out of the computer, they may be negative, they may be positive, and they may be close to 0. This is a regression line drawing. Here's the regression line through the data. It's the same thing we looked at, time and grade. And they say the regression line is the average pathway through the points. It is. That's exactly what it is. They use a method called the least squares method, but that just turns these negative, on the negative side of the line up positive and measures all the distances and finds the line that you could put in there will be closest to all these lines. That's what happens. Here's some that where we can talk about the strength. This first one is a positive correlation, but the strength of this correlation is going to be very good because all the dots are on the line. This is a correlation that's going to be negative. It'll be in the negative realm, and I'll say that'll be about a negative 0.6, and because the dots are distributed on both sides of the line. This one is a stronger correlation than that one up there. This C, it's a strong positive correlation, and I would say that'll be around a 0.8. And this one over here, D, that is probably about a 0.2 correlation, and it has nothing to do with the slope of the graph. It's just 0.2 because they're far away from the line. So correlations can be have values, and we talk about them in terms like weak, moderate, and strong. And here are the values. They call the R values. If the R value turns out to be less than 3, it's a weak correlation. If it turns out to be between 0.3 and 0.7, it's a moderate correlation. And if it's greater than or equal to 0.7, it's a strong correlation. When you write your abstract, you can refer to weak, moderate, and strong, and should in your abstract. Here's some examples of weak and strong. They didn't put any moderates up here. I might point out one. This is a strong correlation. I really don't think this one's weak. I think of this one as being more moderate. And this is a strong negative correlation. Here's a weak. They say that's weak. I guess weak as opposed to what the other ones. This is a moderate. They have a picture of a moderate where they're all pretty close. And this is obviously a picture of no correlation down here on the end. So it'll give you an idea of what we're talking about. So you have a correlation or not. It can be positive or negative, but it can be weak, moderate, or strong. And that's the key to this thing. Don't get correlation confused with causation. Do not indicate any, do not use the word cause in anything you write in a dissertation, because there's a whole lot of stuff has to go into causation, and you're not going to have that. So don't even use it. The Spearman correlation, same. It is just almost an identical twin. It's, I guess, no, it's not the evil twin, but it's the lesser twin brother of the other one, the Pearson. And it runs from -1 to 1, and it's used for categorical data. Well, it's also used, they're pretest to use these correlations. And if the Pearson doesn't meet 3 different pretests, then you can use the Spearman, even though it was continuous data. So in the Spearman, you can use a continuous data, but basically it works very well for non-continuous data, categorical data, like this. Alice and Bill and their ice cream. Alice likes chocolate, strawberry, and vanilla, and Bill likes chocolate, strawberry, and vanilla. So how are these related? Those are a perfect correlation. And the Spearman rho, instead of R, they just call it the rho value, is 1 in that case. And here Alice likes chocolate, strawberry, and vanilla, and Bill likes vanilla, strawberry, and chocolate. Well, I don't know if the Spearman is a -1 because they're oppositely correlated. Chocolate's on top, strawberry in the middle, vanilla bottom, and the opposite thing is true. Here's one where the Spearman's 0.667, and I think you can see that. 2/3 is 0.667, and you can almost look at these small ones here and figure out what they are. Let's go on. Here's an example. A dietitian asks a patient to arrange 5 cards in preference with the most favorite food at the top, and then the dietitian uses another set of cards to show the recommended diet, and they're going to compare the patient's and the dietitian's diet. And the hypothesis is that there's no correlation between the dietitian's recommended food ranking and the patient's preferences. Well, let's see what happens. Dietitian ranks them like this, with vegetables at top, pork at bottom, patient with fish at top and pork at bottom, and this little machine the SPSS spits that out and says, hey, here's your information. The Spearman's rho of 0.9, here's the value for it, is equal to 0.037. That's significant. The 0.05 level indicates a statistically significant strong positive correlation between the food sequences and the dietitian and the patient. So we're going to reject the null hypothesis. We're going to accept motivated hypothesis. Now let's talk about the course project. We're getting closer to you doing a couple of these things. These are a couple of finished dissertations down here. They were finished back in the Noah's days, but they were finished. Uh, in this assignment, you're going to make your first attempt at analyzing one of your hypotheses for your study that you're working on in chapter 4. You will use your fictitious data or whatever data you have from the last assignment. And if you don't like the data from the last assignment, you can keep working on that. You can keep correcting your data until you get what you want here to look at. Now, you can't correct real data, but you can do what you want to with this data. Okay, you're going to do this. You're going to present a data table. You're going to present the descriptive statistics for the data table. You're going to present a research question, and we'll come back to that asterisk here in a minute. You're going to present a hypothesis for that research question, and you're going to describe and discuss the type of statistic that you chose to resolve the hypothesis. And you can get that out of Cronk or Knapp. You can talk about why you chose it, and it tells, if you need a chi-square, it'll tell you why you need it, and so on and so forth. You're going to present the SPSS tables of result when they're generated. The reason I say SPSS data tables is because they are presented in a non-APA format, but I'm going to let you get by with that here. But if you go back up to number 2, you're going to present your descriptives in an APA fashion. And so the instructions will tell you that. You're going to write an abstract for your analysis. Now let's see what this asterisk said. If you plan on using 2 types of hypotheses, let's say you're going to do a t-test and a chi-square, then you're going to have to do, instead of present one situation, you're going to have to present both in your data and your results table. So at this point, it could be best to use only one type of statistics, what that says there. Let's go on and look at this. Here, you can find this in the module. I'm going to give you an example sheet. These are the instructions with exemplars. In this assignment, you will make your first attempt at analyzing at least one of your hypotheses and for your study. You will use fictitious data from your last assignment, and if you find out as you're running through this, you may have to modify your fictitious data. That's okay. We don't mind, because this is kind of a dress rehearsal. You're getting ready. For at least one research question hypothesis, you're going to present a data table and present the descriptive statistics. Whoops, let's go back. And I've giving you example, and this is going to be one of girls and boys being compared for IQ test, and here's what that table descriptives is going to look like for you. And notice how the table is made. This is an APA formatted table. There's only about 3 lines in three horizontal lines in an APA table. One under the title, which is written in italics. Table notice is written in regular print, double spaced. The title right on top of the first line. Some information here, identifying information, another line, and a line at the end of it. That's a APA table, folks. You present your research question, and is there a difference? And you might say the word significant if you want to. Is there a significant difference in the performance of boys and girls in the 9th grade administration of the Hinman-Nelson test in Craighead County during the fall? And then null hypothesis, there is no significant statistical difference in the performance of boys and girls on 9th grade. So I'll give you an example of everything you need to do here. I don't know why I keep moving that. Then you're going to make a statement about the statistic. And I think I went back to Cronk and got this. An independent samples t-test is a test that was chosen for analysis of the hypothesis. The independent samples t-test, that should not have an S on it there. But anyway, you can read about that. You just do the same thing. And it talks about the alpha level and that sort of thing. So that's what you want to make that statement. And obviously, later when we do the real thing, you're going to have to do that as well. Okay, you're going to present the SPSS tables that were generated. Okay, and I tried to make these look like the SPSS tables. So on a t-test, you're going to get a table that looks something like this. It's going to give you almost a descriptive statistics table. It's going to give you the n value, the mean, the standard deviation, and the standard error. And then the t-test table, you notice I've got